So let's start our today's session. So yesterday we were discussing about the variables and the types of variables, and also we understood how we can declare the type variables in multiple ways. And coming to types of variables, we have understood what is local and package level, and also the exported variable. When I try to explain, we got some errors related to the workspace. First, let me cover some information about the workspace, and then we'll understand the exported variable, and then we'll go with constant pointers and data types. So today we'll stop the session by 8. Um, So, what is workspace? So, for now, what we understood with respect to the project structure in Golang, so we have modules, and module is basically collection of package, and then packages basically consist of source code, that is core source code. So again, when it comes to module, how you can manage multiple modules in a single workspace. When you install the Go or when you start working of any Go project, then you will get some default location, what we see, right? For the when we lease the Go environment, we will see the Go path. In the Go path, it is set for the project environment. So basically that is a workspace which is by default will be there. So when you want to work with multiple modules in the same workspace, you have to enable the workspace feature with the help of go.work file. So that is basically, so to handle different modules in the same workspace, we have to explicitly create this go.work, and to understand actually how many projects are there and how many modules are provided inside the particular project. Because when you see in the production environment level application, you will see single go.mod will be present in a workspace, and you won't see there is a two or more go.mod is present in the different modules. For example, if you take Kubernetes as an application, in the Kubernetes, you will only see the go.mod as a single file inside that Kubernetes repository. Similar way, here our structure is little bit different, where we are creating multiple modules in the same workspace. That is by creating the go.mod in the day one, and as well as in the day two, I have created this go.mod. So when it tries to import the package, right? So that is custom package which I have created here. So using this path, but it is not able to find in the github.com slash in my account as well, because currently this package is not available in the GitHub. So it is it will first search for the GitHub. It is not able to find out. Then it will come in the local cache where exactly this folder is present, but I did not give any reference to a particular module. If, for example, GitHub path is not available, then you have to refer the local path. So that is what I am specifying here. These are the folders which are currently in use in the workspace. So when you don't find this particular package, that is package 1, inside this module, then try to see this go.workspace, and you will get all the details about what are the modules which are currently present. Accordingly, you can do the import. So it is basically when you are doing the local development task, you will mostly every time not going to push the this particular module into the GitHub. When you are making the changes, you are going to push and maintain this code. But when this package is available in the GitHub, then you can directly access that. But currently, I did not push it, so that's why uh, it is not able to find this particular path when I provided this import path. That is, here I have provided github.com pretns, and this is the path I have provided. But it is not able to find in the github.com as well as it is I have not linked this particular module in the go.workspace as well, because once you're not able to find in the github.com, please go to the workspace and find whether any modules are present. Accordingly, navigate there and import the package. So this is what I'm telling with respect to this go.workspace. So this is the new feature which comes after 1.81 version of the Go. But before that, we have a different approach, that is using the replace in the go.mod itself. But why we are not following the previous approach? Why we are going with this new approach? Because when you push this code, right, you will not going to push the go.work in the normal development day-to-day activities. You are going to push only the code, because we are not adding that changes. That is, once you don't find this GitHub path, then don't search it for local sync, because once you push the code to the GitHub, there is no access to the local cache. So that's why when you are pushing this entire project, so then uh, you will not make changes in the go.mod, but you will create this go.works, that is a workspace file, where you will be mentioning, if in case you are not able to find it in the github.com path, then try to refer the workspace file. If any particular folder is present or module is present, and try to like use that path and use the module accordingly. So whenever I want to import this, so this is where the workspace comes in. And again, when you have multiple modules, that time also we will create the workspace. It is give the better readability. What are the modules are present for the Go compiler as well. When it tries to run or import some of the packages, it will not get any confusion. So that is why we are going to use the workspace. So for now, let me delete this as you like how I created this go.work. Let me do that. So currently when I delete this, we will get the error. Let's, it is saving. Let's wait for 1 minute. And so currently when I remove the go.work, it is throwing this error saying that could not import github.com, cannot find package in the go root or go path. So now what I'm telling is, so let me, so now I am in the day2 folder. Now I have this package one. So that is a new package, custom package which I have created, and I have provided this exported var which assign the 30 value. Now I want to import this or I want to use this exported var in my main package. So when I want to use it, I want to provide this import path. Currently it is throwing an error because in the GitHub path it is not able to find out. And also in my workspace, if there is any module also, I did not provide that reference. That's why currently I'm getting that error. So now let us create the go.work file using the go work init command. And you can also explicitly provide the day1 and day2 folder in the command itself, or you can also change it in the go.workspace. So go.work is an editable file. You can also use the command that is the use and followed by braces and provide all the modules which you have created inside the workspace. So now let me create the, you can provide multiple module names here, but currently we have two. So let me create that. Sorry, I think I need to go back to this Golang session because I need to create in the root directory of this Golang session, not inside the day2. So let me execute this. So now it is able to successfully create this go.work and added all the modules which I have specified. So now let me say this. It's already saved, but yeah, it will take some time to import. Let us wait for that. And again, if you now once I provided this reference, try to refer in my Go workspace, then it is able to recognize it. Okay, this is the path I want to import for this package one, and it is already, like, it is successfully imported. So now if I run this program, so it will print the package level variable. So that is the value which I have provided here, that is 30. And again, the package level variable exported variable which I have provided, that is also 30. So this is the two value which gets printed. 1 second. Okay, so now the error is resolved. And finally, we can also able to print the package one. So how I am accessing it directly here. So let me remove this. Here I'm providing the package name followed by the variable. So it is already giving the suggestion because it can be exported. So So like once I remove the package, if I didn't use that, then by default Go will clean up the particular import path which is I'm not using. So once I remove that package one dot exported var, so it is once I saved it, it is completely remove that module itself. So you have to provide it again to work. This is day2 and then followed by package one. So I'm giving the alias so that instead of every time I need to print the package one, day to package one. So you can provide the alias here so that every time when you want to use the package one, you can just use the direct naming here. So you can name anything here. So this is just an alias for the simplicity purpose. So for example, if I use PA1, then I can use the here. So this is just an alias for accessing that package throughout your program. So this is the exported variable. So even in the package itself, if you don't provide this capital letter, if you just start with a small letter, this will be treated as a package level variable only because it is not accessible from this main package because it is not exported. So if you still able to see the suggestions, but it is giving the error, it is undefined because it is not able to find the exported variable. So if you want to use in another package that is outside the package, then you have to provide the capital letter for the variable name. So that is mandatory here. So this again, whatever I have declared throughout this package one, I can use it. So that is using this exported, but outside the package, that is from the main package, I can't able to access it. I hope this is clear. Or any questions?
The variable name can be anything, right? But it
Yes,
should
yes.
start with
Variable, yes, capital letter for the exported when you want to access from the outside package. But if it is a
if
normal
the
variable name that is starting with small letter and outside the function, then it is treated as a package level variable. So throughout the main package, it can be accessible if you declared inside this main package. Even if you declared exported as like starting with small letter, then throughout the
yeah,
package one, it can be accessible. Yeah.
yes, understood.
Okay. So now let us understand the constants. So now we understood that variables can be changed anytime. That means once we declare variable and you can assign value and also you can change it later if you want it. Means from 10 to 20 you can still you can able to change it. So that is if I just print out the value of a, that is the latest value of a get stored. That means the if I print after this assignment that is 20 which is assigned to a, so I will get the value that is 20. But if I print before a, then I will get value that is 10. So now let's keep this. And if I run this, it's successfully worked as the name suggesting in the variable. You can vary the value or you can provide any value you want in the like in different logic as well, but it's not mandatory. Like once you provide the value, you can't change it later. So that is not there in the variable. So variable is always give the flexibility to change the value. But sometimes you want to keep the value for the variable always same, or throughout the program you want to keep the value of the variable, it should be same. Then how you can do that using the constants. So how we can declare the constant is basically so using the const keyword instead of var keyword. So these are keywords which is reserved words from the Golang. You can't use it for any other purpose. For example, if I want to declare a variable name, as I mentioned some of the naming convention we follow, right? So similar way, even during the name of the or providing the name to the variable, you should not use all these keywords. For example, I can use or I can provide directly constant as a variable name here, but the Golang is not going to support that. You should not use the any keyword which is already provided from the Golang. So that is, for example, if I provide var constant, for example, integer. So I'm trying to assign some value. So this is not allowed because constant is a keyword. So it is not able to uh, or it is not able to give the flexibility to create the variable name with the keyword. This is also one of the rule you have to follow when you are defining the variables. So there are again multiple keywords are available. If else for whatever we are going to use with respect to the concept, for every concept there is a keyword. So you can't use it for any other purpose, but to build the logic or to create loops, to create conditions, those things you have to use the particular keywords. So similar way, here when I want to create the constant, I can use the const keyword and I can provide, for example, pi is a constant value. Throughout the logic, you will be using the same value for the pi. So you can declare using the capital letter because constant is, we mostly go with the all the letters should be or all the uh, or variable name you are providing that should be capital always. But you can also provide these kind of variable names as well. It is also allowed, but for the differentiation and also from the variable, if you want to get the clarity when you are writing the code or reading the code, then you can better to use the this pi and throw the package as well as and outside the package it's still able to access it. So now I will provide, for example, float 34. So 3.14 is a floating point number. Let me provide. Right. So now what I'm telling is pi is a constant which is of type float 32, and you can you don't need to provide this as well. It will infer the type according to the value. So as we discussed for the variable, we have the type inference concept. So based on the value, it will treat this as a float value. So this is also allowed. So now if I want to change this constant, right? So that is not allowed here. So for example, I don't want 3.14. I want to provide 3.145 now. So what it is telling, so cannot assign to the PI neither addressable nor map index expression. That means it is indirectly telling it is a constant type. You can't able to assign in the next line. That means once you declare and initialize it, you can't again provide the new value in the later logic. So that is the benefit of constant. When you want to use the same value throughout your program, you will be using the constant. So even constant can be declared outside your function as well, so that every function can be accessible at the package level also you can declare. So this value throughout the function, whatever the function you are going to do or create. So in those functions, this constant will be available and the same value we are going to use it. So in the later logic, if you want to change it, then it is not possible to change the value. So that is the basic or need or importance of the constant. I hope this is clear. So it doesn't have any much importance as compared to the variable. But only thing is if you want to keep the value throughout the program should be same, then you will be defining, declaring and initializing once, and that value will be used throughout your program.
With a small doubt.
Okay.
For constant, the value will be constant, right, throughout the program. You said, right?
Yes.
Yeah. Suppose if we give an constant and we give assign one value for it, after
Okay.
outside the function, can we use the same, or we can
So
use different?
when I Okay, so when I declare this, right, this is a package level. That means throughout the function, it can be accessible. So that is what I'm telling. So in the main also, this particular pie is accessible, and in the add also, if you create more function in that particular function also, it is accessible. So now, for example, I have created this. Let me create this 3.14. Let me delete this. And if you want to print this, it is giving the suggestion. That is, whatever it is we have discussed for the variable. So everything same applicable to constant, but only changes is wherever you declare or whatever the value you are going to provide, that should be constant. But for example, let me provide the same thing here. So again, in the scoping, when you are dealing with a scope, right, always the local scope has the main priority. So that means, let me write it here. Now, what I have done is, I have, let me write it down first and then I will explain. So currently what I have done is, I have provided the constant variable at the package level and the exported variable as well. So exported variable, you don't need to worry because we are just importing the path and we are just referring the particular constant value. But when it comes to package level and the local scope, right? So which has the highest priority when I try to print the pi value inside the main function. So it is actually going to refer the 3.145 instead of this 3.14 which I have specified. You can provide the multiple declaration and initialization outside the main function as well as inside the main function with the different value, but it has the priority when it comes to local scope and the package level. So local scope has the highest priority. That's why even if you provide the constant pi that is holding the value 3.14 at the package level, still it is going to use the local scope, that is 3.145 when it tries to print out. So, but again, once I declared an initialize, I'm not changing it here. That is, here I'm not providing this syntax, that is 3.145. This is not allowed because when you don't provide the declaration and initialization inside the local scope, then it will definitely try to refer the package level, whatever I have declared. So now what I am telling to the Go compiler is that, so I have declared and initialized at the package level. Now I want to modify in the local scope. This is not allowed. That's why it is giving the error. So that is cannot assign to pi. So you cannot modify once you declared and initialize. But you can still recreate that constant variable and provide in the local scope or in the package level. Still you can able to change the value. That is allowed. So if I run this program right now, okay. So let me okay. So this will print the 3.14. Let me show that. So as you can see, this 3.14, which is printing from this exported variable, and 3.145, still I have provided pi as a package level variable and also local variable. Still it is going to print the local scope because local scope has the highest priority than to the package level. So, but you can't assign the different value to the already declared or initialized in the local scope or in the package level scope. But you can recreate that by using the constant keyword and provide different value. So that is possible. I hope this is clear.
Yeah, yeah, Preeti.
Okay. So, like in general, if you talk about when you are trying to create a constant, we usually create the constant in the package level only, because whenever the constant should be used in the any different function in the or throughout the particular package, then you will be specifying outside the function itself. And for example, you have multiple constant and you want to, like for example, let me create one more constant here. So let's like I am giving the random name here, but based on the, for example, you have token name. So you will have this token name throughout the program should be constant. Then you will be providing some value to it. So then again, what I am doing is in multiple lines, I am providing the constant declaration. Instead of this, there is an another way. Instead of providing multiple declaration here, you can provide the const keyword once and put all the constant inside this braces. That is similar to import what we seen right here. So it is similar to when you have multiple packages to import, then you will keep all the things inside this brackets. Similar way, here also we are going to use the constant keyword, and inside that we are like providing these braces, and then we are putting all the constant. So this is one advantage again when it comes to variable also. When you want to provide the variable which is of the same type, you can also keep uh, using this braces. So but it should be of same type again, or if you want to create, for example, str string type, then you want to explicitly provide the type. So this is one advantage you will find. You don't need to provide multiple multiple things in the different lines. Instead of that, you can group all the variables and constant like this when you are providing at the package level. So that is the use of this brackets. Even you see for the import statement, right? Here also we are doing the same. So currently I'm not using the str. That's why it is throwing the error or some suggestion str is not unused or not used. So this is how you can make like write the code in a very flexible way as well. Remove this. Currently we have one, so that is enough. So let me remove this as well. So now we have the next concept is pointers. So again, we have to compare pointers with the variable. So how we are going to declare a variable? We are just using this var keyword and provided the variable name, and we are specifying this is an integer type. So now when it comes to pointers, how I can declare the same variable with the pointer concept? So I have to just use this asterisk symbol and provide the, so here in the pointer, we are not going to store the value, but we are going to store the address of another variable. So let me explain it in the whiteboard. So basically, uh, what is pointer? So pointer is basically holds the address of another variable. So I will tell where exactly this pointer will be useful, why it needs to hold the address of another variable, why we need, like we have already the variable concept, why we need to provide this or use this pointer in the programming. So how we can declare the pointer is basically using this asterisk symbol before the data types. That means I'm telling, so this x is a pointer which holds the address of another integer variable. So when you want to assign the address to this particular pointer variable, then you have to assign the address of integer variable. That means you have to create a integer variable. Let me take y, which is holding the value that is 30. And now what I am doing is here, let me assign the address of y to the x. So basically what it is happening in the memory. So let me draw this. So basically we have y, so which holds the value that is 30. Let me provide 30. It has its own address. For example, 0 x1234. So this is the hexadecimal address which we have for the y. So now we have x, and x is holding the address of y. That means it is not storing the value, but it is storing the address. So now what is the x address here? It can be in any random again. So it may be 4567. So the x address and the y address is totally different, but x is holding the address of another variable which is holding the value that is integer. So that's why when you specify the or declare the integer type, you will be mentioning which type of which are like whatever the address is it is holding, which is pointing to integer or float, you have to mention it. For example, you want to create another pointer variable which points to the float, then you will be specifying the float type. So this particular pointer, where it is going to point out whether it is hold or point the integer type of variable or float type of variable, that you have to specify during the declaration. So again, why we need this pointer concept when we have the variable. So basically, when you want to pass any variable to the function, so I will show in the demo. For example, you have the main function, and in the main function, you have declared a and b as an integer. So you have the add function, and where you want to perform the addition of b. So that means you are passing the variables from the main to the add, and you are performing the addition in the inside this add function. So now how the pointer will be useful, and when we use the variable, how it is going to happen. So for example, let us understand with a variable and then we'll understand with respect to the pointer. So when I use the variable concept, that means when I try to call this add function from the main, because to work or to execute the logic of add, I need to call from the main function. I will explain this concept when we get into the function concept. But what I'm providing here, so I'm passing this a and b variable which I get created inside this main. So I'm just passing this as a variable. So now what add is going to do is it will accept the a and b value. For example, you are assigning 10 and 20. So here you are passing the a and b as a value that is 10 and 20. This add function will also accept the 10 and 20, and it will perform the a plus b, that is giving the 30 as an output. But in terms of memory, how things are happening. So when you pass, for example, there is already A and so when you are inside the main function, there is a and B variables gets created. So here we have the B, and here I have provided 10, and then I have stored here that is 20. So here I have stored 20. So when you inside the main function, this is what created, and it is holding the address, for example, 0x1234, and it is holding the address that is, for example, 0x4567. So when you pass this variable A and B to the add function, there is a new copy gets created. It is not working on the same address and the same copy, but the values are same because you are just assigning or creating the copy of it. So whatever the value are provided, that gets copied into the newly created A and B. But what actually happening when you use the variables, it is creating the copy. That means when you pass inside the add there is a and B gets created with a new memory address. So A and B. So even you can provide the same name or you can also provide the different name. But it is creating the copy of it. That is, it is holding the value that is 10 and 20. But when it comes to memory address, it is using the different location. It is not using the same memory when it is inside the main function. For example, it may be 0x6789. It is having the address, for example, 2567. So here 0x2567. So now here also we have the a variable which is holding the 10 and it is creating the new copy. Even if you can provide the different name, that is also possible. But when you pass the value as a variable, then it will always create the copy in the memory address. So that is actually we call it as a pass by value concept. So when you talk about pointers, right? So what you will going to do is you will instead of this, you are going to provide the address of A and address of B. That is, you are providing the entire reference of A and entire reference of B. So when it pass to the A, it will accept this as a, okay, let me provide it here. So it will accept as a pointer A and pointer B. So now things will change. It will not create a copy, but it will act on the same address. So for example, address of A, it is pointing to here. That is, A is pointing to the same address where the exact the 10 value gets stored. So now this particular A is act as a pointer which holds the address of, or maybe you can change the name if you are getting confused here. You can also change with the X and Y here. So even for the pass by value you are creating, it will create a copy. But for example, this X is a pointer which is holding the address of A now. So whatever you are going to do the operation, so that will on the same address. For example, you want to change the value of X now. So currently we have the value of A that is 10. When you want to change the like you will be using the some operator to access the value which is inside this A. So now you can change the values to like something as well inside the add function. That is, when you change this or provide this statement from 10 to, so this will override by the 20 value. That means it is happening in the same memory location. I'm not creating any separate location here in the memory. So pointer will save the memory for you when you are like dealing with pointer. But when you are using the pass by value, or you are passing something into the another function, or you will be using the struct concept and the method. So when it comes to the struct and method, we will be dealing with a large type of data. Every time you don't want to create the copy of the entire data, so that time you will be using this kind of pointer concept. So that will like points to the same memory location where original set of data is present, instead of creating the copies in the memory location again and again. So this is we call it as a pass by pointers. So when you use the concept of pointers, but when you use the concept of variable, that time you will be going with the pass by value. So just for the summarize here, so pass by value is basically you are when you are trying to pass the variable values to the another function, it is going to create the copy of that, and it is allocate the separate address for each value to hold it. And when it comes to pointer concept, it will work on the same memory address. Whatever the changes you are going to do in any other function, that will affect in the original value. But in the pass by value, whatever the changes you are going to make, that will be done on the copy of the particular variable, not in the exact original copy. So this I will show in demo, but concept wise, any doubts or any questions? No doubts. Let me provide the example so that you will get more clarity whatever I have explained. So currently I have one variable which is of type integer. I am telling x is a pointer by providing this asterisk symbol, and I am specifying you need to point to the address of integer variable. So now what I am assigning to this pointer, address of y. So now let us print out what actually X contains, and and also I will explain there is a reference operator and dereference operator. How you can use the dereference operator to access the value which is present inside the Y from the pointer. So let me explain this. So for example, now as we know, X is a pointer. So when you use the asterisk symbol followed by the pointer name, that means you are indirectly trying to access the Y value. That is whatever the Y which is holding, that is 30. So when you provide this asterisk symbol followed by the pointer name, that will provide the value that is 30. But when you provide just the X, then it will give the address of the particular address which is held by the X. So that is here in this case we have the address of X variable, that is 0x1234, and we have address of X. So what is address of X? It's similar to a variable. So you will get the address of this particular uh, pointer, that is 0x4567. So when you use the dereference operator, this we call it as a dereference operator. So you will be using for declaration of the pointer as well. So you will be using this operator to get the value which is present inside this y, and as well as you can do modification using the pointers as well, and also using the direct variables as well. So now when you provide the just the x, then it will get the value which is present inside this pointer. That is, it is holding the address. So that's why we are getting this 0x1234. So when you provide the address of x, it will provide the address of this pointer. So now let me show it in output. Currently, as I mentioned, we are declared pointer using this asterisk symbol. That is the only difference when you are trying to declare the pointer. When you want to initialize the pointer, then you will be using this address operator and provided the variable name. which type of variable you want to reference. Now this X is currently pointing into the uh, Y address location. So now let us print out X first. So what X is actually holding, and also let us print out Y address as well. So how you are going to print out the Y address using the address operator. So when I provide this statement, so now this output and this output should be same, because when I provide the X, I will get the address of Y. As I mentioned, when I provide the X, I will get the value which is present inside this X, whatever it is actually contains. So that is address of this Y 0x1234, 0x1234. So when I want to access the address of Y, I will be using the address operator like we discussed with respect to the variable, right? When you provide the address operator followed by the variable name, you will get the address. When you just provide the Y, then you will get the value. So now for this output, I should get the same address because X is also pointing the same address, and we are directly accessing the address of Y to verify whether this particular pointer which points to the same address or not. So now let me run this. So as you can see, the same address is got printed here. That is address of Y, and the X which is pointing to the address, that is also same. Now we understood that okay, the pointer is always contains the address, not the value. So now if you try to assign value to it, right, it will give an error. For example, if you try to assign directly the value to this pointer, so then it will cannot use 30 as a star int. That means it is a pointer type. You cannot assign the value, but you can assign the address of the variable. So now let us see how we can access the 10 by using two different way. One is using the variable and another one is using the pointer. So let me print out. First is using the Y. We just need to provide the Y variable which holds the value that is 10, and then I'm going to provide. So when I try to access the value which is pointed by the pointer, then I will be using the dereference operator followed by the pointer name. So both these pointer should, or both these values should give the same output. Let me clear this. That is through the pointer you are accessing, as well as directly with the help of this variable you are accessing. So both are pointing to the same, that is which are directly accessing the 10 value. So now if you want to get the address of pointer variable itself, then you will be using address operator followed by the pointer variable. So now if I run this, so as you can see, the address for these is totally different because X is pointing to the address of Y and Y is having its own address. It is totally different from the address for the particular pointer variable, that is X. Any doubts here? I will show how you can pass the values and how you can do the pass by reference or pointer, so that um, when there is a changes you made through the pointer, how it will affect the original copy. And when you are using the pass by value concept, if you make any changes in the copies also, but it will not affect the original A and B. So I will show that. But for now, related to the pointer concept to access and to like hold the address of another variable, is that clear?
Yeah, yeah, Preeti.
Okay. So let me create one add function because the pointer concept is very useful when you are dealing with multiple function and you are using struct and methods. But again, we have the struct and method concept separate. So I will discuss how we are going to use make use of this pointer in the struct concept as well. But for now, to understand how variables works or how pointer works when you pass the reference or pass the values directly to the another function. So, or you can just call it as modify here so that it will help us to understand. Okay. So now what I'm going to do is let me call the modify here. And here I'm going to remove or like I will just comment it out. So for this modify, I'm going to pass the address of y. First, let us see for the variable. So currently what I'm passing is I have declared the y and I'm using the modify function and I'm just directly passing this y to the modify function which I'm going to uh, define it in this separate function. So now when I try to hold this value which is coming from the main function, so now how I can do that? I can create another variable here. So that is this we call it as a receiver part and this whatever we are passing that is actually we have separate concept again arguments and the parameters. So here I am receiving this y value inside this or with the help of this z variable. So now what I'm going to do is let me modify the z. That is for example 30. So now what we have y is a so now what we have done is I have just created the y and I have provided the value that is 10 and then in the modify function I'm just accepting uh, this y as a z variable. That means it is creating the copy and now what I am telling is for the z currently it is holding the 10 value that is 10 here and then in the modify function what I am telling is try to modify this z with the 30 value. So now what it is going to do is it will modify the z address that is replace the 10 by the 30. So now it will not affect this y. The y or whatever the value which is holding, it is keeping the same. There is nothing like or there is no relation between these changes with respect to this y. So now what I'm trying to do is I will print this value here and here I'm going to print the value. Here I'm going to print the y. So that is after calling this modify function, there is no effect on my original variable because there is no relation between this y and the z variable. So I am just directly, okay, it's not a problem. So I am directly telling, I just modify this z and it is like directly modify on the z location but not the y location. So when I try to run this program, let me run this. So now as you can see, okay, in the modify, when it comes to modify, don't worry about this result. It is above whatever we have typed, but like see this result, what we got here. So we are just passing the y reference y as a variable directly to this z, and whatever the value which is there, it is copied, and the z new location gets created, and we are just modifying the value. So it is not affect the y value because y still holds the value that is 10 now. So that is what we understood from this diagram. So that is, it is changing in the z location, not the y location. So now I want to change it in the y location only. I don't want to change it in the z. Even if I make changes in the z, it should be or it has to reflect in the y as well. So now how can I do that using the pointer concept? So instead of just the variable, I am going to provide the address of variable. Here I am going to create a particular what pointers for this. That is, it is created the pointer now, which is holding the address. Now I'm changing this value, which is uh, directly referring this y. So now what I am doing is currently this z is act as a pointer. So let me create one more uh, uh, box here. So that is memory. So where the z is act as a pointer, and it is holding the address of y. So that is, for example, the y address is taken the example of 0x1234 only. So now this z, which is holding the value, that is the address value, which is there in the y. So now I'm indirectly referring or accessing the value which is present inside the y through the pointer using the dereference operator. That is what I am doing here. So that is star z equal to 30. So now if I print out the z here, and here if I print out the y, so there is a changes. That means it will not hold the value 10 now, because through the pointer I have made the changes to the y as well. So now let me run this. You can see there is a 30 30 30 like previously we got for the y value it is 10, because whatever the changes you have done here, it is not reflected in the y. But when you are using the pointer concept, whatever the changes you are going to make through the pointer for the variable value, so it will affect the original copy as well. That's why for both through the pointer and as well as using the variable, we can able to see the same value. So this is the major difference we will see when you are using the pointers and the variable concept. I hope this is clear. Any questions?
Same like C language.
Yeah, the pointer concept is, but here when it comes to garbage collection, it is more like when it comes to memory management, it is advanced here. But compared to C, the pointer concept is same. But coming to garbage collection and memory management, when I try to explain what is heap and stack memory, you will understand that how things are happening, and also how garbage collection is improved in the Golang compared to the C. But again, Go is built using the C concept as well as like C, whatever the C concept which is there. So many things are not there in the Go, but for the simplicity purpose. But most of the concept which is very important to build a particular service, so those things will be definitely there. So it is again similar to like some of the concept which you have seen in the other languages as well. But coming to memory management and garbage collection, you will understand how these are happening inside the like when you execute the program itself. So that is where actually the difference comes in from the different language perspective. I will explain when it comes to memory management concept. So there we have to understand what is stack and for example, when I write this function, how it is storing in memory, and when I'm not using the function, how it is deleted automatically from the memory or cleanup is happening. So those are again some low level concept of the memory if you want to analyze it. So, yeah. So with respect to pointers, any doubts? We can stop here. Maybe we'll continue from tomorrow. So we have data types as the next topic. Any question in today's session?
We are good.
No, Preeti. Yeah, it's good.
Okay. So then we'll end the call. Thanks everyone for joining.
Yeah.
Yeah, thank you.